Hi, my name is Brian Soliday, and I manage sales in the Rocky Mountain region for One Spatial. I'm based out of the Denver area in Frederick, Colorado. I'm joined today by Melissa Ubaldo, one of our talented solution engineers. Melissa is based in our US headquarters office in Vienna, Virginia. I want to thank everyone for joining us today to talk about challenges with geospatial data. We'd also like to thank the Utah Geographic Information Council for organizing the virtual UGIC 2020 event. I'm sure we'd all much rather be doing this in Park City or St. George, but hopefully next year we'll all be able to get together face to face. Today, we'd like to focus on some work we've been doing with a variety of organizations across different industry segments at the federal, state, and local government levels, as well as within the commercial space. We're helping them navigate how they handle the constant changes to the data coming in and dealing with those constant requirements on that data and improving those management processes. For those of you who aren't familiar with us, One Spatial Inc. is a U.S. company that's a wholly owned subsidiary of One Spatial Group out of the Cambridge in the UK. The organization began its life over 50 years ago at Cambridge Labs within Cambridge University, and Cambridge still serves as the organization's worldwide headquarters today. Our U.S. headquarters is located in Vienna, Virginia, with satellite sales offices in California, Colorado, Texas, Georgia, and Pennsylvania. Additionally, there are One Spatial offices around the world, all providing local support and technology implementation for our growing global customer list. We have significant experience across a number of industries, including federal and state and local governments, transportation and infrastructure, utilities, both electrical distribution as well as water, and facilities management. One of the keys to our success is a solid technology partnering approach. The One Spatial team on a global level has significant experience in ancillary technologies that are key to our joint success. Several of those key partners are listed here. At its core, though, One Spatial focuses on data management solutions to improve the data quality of large, complex systems. We use validation, integration, automation, and our rules-based approach to build strong data infrastructures, leading to better outcomes and making your data smarter. As I mentioned, at One Spatial, we have about 50 years of experience developing data management solutions. In the US, we're a little bit newer to the market. We started doing work here in the US about 7 years ago, and with the very first customer being the US Census Bureau. Since then, we've expanded to nearly 50 clients in all of our key sectors, predominantly in, like I mentioned before, the federal, state, and local, transportation and utility and facility management segments. Listed here are many of our other customers that have come on since Census. Some of our projects with these customers are supporting them with our rule-based approach to conflate, validate, and integrate their data. This data could be focused on addresses, next-gen 911, transportation data, utilities, as well as spatial data infrastructure projects. Some of the organizations we have worked with include groups like the state of Nebraska, where we're working with the state on automating their processes for taking data from their CAMA, their computer-aided mass appraisal system, and validating the incoming data and integrating it with their GIS. We work with a number of GIS departments on building automated validation workflows. We help organizations such as the state of Michigan as well as Arizona DOT on their spatial data infrastructures, building automated workflows to ingest updated data by first validating the data that's coming in, then performing a change detection to not only find the deltas, and then integrating those changes into their source data sets to maintain proper metadata. Lastly, we're working with organizations to help them with facility management applications. So organizations like Google's Real Estate Worldwide Services Group are leveraging One Spatial's tools and services to implement validation of their CAD drawings to assist in the easy ingestion into their asset management system, IBM Tririga. We have also implemented validation workflows to help them in terms of validating that Tririga database directly. Our focus has been working with organizations on implementing automated tools to perform quality assurance and quality control on spatial and non-spatial data sets, performing change detection, integration workflows to keep systems up to date while maintaining historical metadata. One case study I'd like to briefly discuss our work with our first customer in the US Census Bureau, and their MAF Tiger conflation project. Census was receiving data from over 3,200 providers. Each of those data submissions can be in different format based on different standards and utilize different schemas. We worked with Census to create an end-to-end solution to bring that data into the system, run it through our One Integrate engine to validate the data, map the schema into the required census schema, and then run change detection on that data. There are two actions for changes that we find in the data. For the changes that fall within the census threshold, we automatically update and integrate that data into the database. For any that are determined to be outside those thresholds, however, we create what we call proposals for manual view by a census analyst. Any of those proposals that are accepted by the analyst will go back into the automated process, while others will be handled manually. From there, the data sets are updated and the project rolls on. This at one point was a very manual process, reviewing the data, which also introduced a fair amount of subjectivity to the corrections that they were making. We're proud to say this process is over 90% automated since leveraging the One Integrate solution. We're working with Census to get this in the very high 90s percentile range. So with that, I'd like to hand it over to Melissa, who's going to cover detail on what we mean when we refer to data management, and then provide some real-world demonstrations that have been built during engagements with some of our clients. Melissa, it's yours.
Thank you, Brian. So quite obviously, all of the clients that we have worked with so far have very different business requirements. But to develop data management solutions for each and every one of those projects that Brian mentioned, we did apply the same rules-based approach using our highly configurable automated rules-based engine called One Integrate. It lets you author and customize your business rules so that you can first and foremost validate your data by finding anything that fails your rules. You can connect across the entire enterprise and write rules that will integrate your data with other sources, specifically the ones that are supposed to be maintained synchronously. You can also write a rule to automate how you want your data enhanced so that the next time you run your data through the same validation rules, they'll conform to the data quality standard that you've set. But regardless of what type of data you manage, maintaining data validation processes is valuable. I'm sure we're well aware of the importance of having clean, accurate, and current data. And we also recognize that data is dynamic, as in fact subject to change. So how can we ensure that high data quality standards are sustained? This is the very basic but persistent challenge for state and local government to get their addressing data NextGen 911 ready. The business rules, or the guidelines that your data has to comply to, have been laid out in the form of the NENA standard, or the National Emergency Number Association. Before we can jump to a quality check, such as checking that an address point within a PSAP boundary share the same PSAP boundary name attributes, as an example, we have to first establish that these features follow their respective standard schemas. So in this case, that would be the NENA standard JS data model. So using products in One Spatial software suite, let's run through the process of how Los Angeles County is trying to assist their jurisdictions to submit data to them, in particular, data that actually meets the set of business rules that they've set up. This is the One Integrate rules engine. What we're seeing here is a list of tasks to make up a workflow within One Integrate, which we refer to as a session. A session always starts by reading in our data and loading that into its cache. What follows is a series of rules that we are requiring our data to conform to. So let's take a look at some of these examples. We have essential geometry checks in here, such as checking for kickbacks and spikes. We have rules for our roads, such as checking that all of our roads have names. We also check that our road network is well connected. For address points, we have some inner feature checks here to help us verify their positional accuracy. So in here, we're saying that if they are located inside building footprints and or parcel polygons, then their address information in their attribute tables should match up as well. Another example of rules related to addressing are checking that in relation to how a road has been digitized, there should be no gaps, overlaps, or parity switches between their address range values. So once a rule has finished running, we start seeing instant results as conformance rates. So this indicates the percentage of the data that conform to the rule. So if it's not 100%, it means we have non-conformances. Let's take a look at one of these where we have 99.98 for our kickbacks. And let's go ahead and take a look at that kickback through our cache map viewer. What we can do from here is find out why and how our data does not conform. So we take a look at here real quick on the report. We are driven to the exact location of that kickback. But of course, if you prefer reviewing these issues to a GIS application instead, we can export those out as well. So I've actually done that beforehand. Let's take a look at some of those non-conformances. So I've loaded in my markups in here, and these drive a location to all of my non-conformances and tell me which rule those objects actually failed in. So right now we are looking at what we just saw in that cache map viewer. We have in here our kickback on this road segment. Again, what's nice in here is it's actually telling us the vertices that are involved in this kickback. One Integrate is able to do the same for our spikes, where it drops a pin on that vertex causing that spike to occur. Let's take a look at one of our attributes checks here. Now what I want to show you here is why it's valuable within One Integrate to write a rule in a positive language. By saying that the zip codes have to be a positive integer between an expected range of valid West Hollywood zip codes for this jurisdiction, we were able to find the null zip code right here on this road. So it's definitely a much more efficient and simple way to write a check by stating what makes the data correct or how is it going to meet our business rule, as opposed to listing out all the other possibilities that would make this value wrong. For this rule, we said that a named road centerline within address range values should have at least one address point that belongs to it. So if we turn on our labels here real quick. So for Rangeley Road, we do have some valid values in here for our address ranges. However, if you take a look at this map extent real quick, we are not seeing an address point that belongs to Rangeley. Now, it doesn't mean that this road is invalid, but it's one of those validation rules that's just nice to have, just to verify that we didn't make any mistakes by naming things Rangeley. Let's take a look at another nonconformance. For this rule, we were checking that we should only have one address point inside a parcel. And if I select these address points here, we're seeing that these two address points are stacked on top of each other, very different address information there, and our parcel only matches one. We also have address points that fell outside of our buildings. So in here we're seeing that this address point got flagged because it is outside a building footprint for 9025 Lloyd Place. So now that we've seen what kind of non-conformance we have in our data, let's go back to One Integrate and see how we can automate fixing them. So the actions that we have here are actually rules that can modify our data. So what we're going to do is smooth out our kickbacks and our spikes. The build topology here will address our topology alignment issues. And if we find any address points outside of buildings, we check for possible building locations within certain parameters such as distance and similar address information. By rerunning some of our rules here at the tail end of this workflow, we're able to determine if our cleanup actions worked as expected. So if they did, then we can go ahead and push an export task to provide us a copy of our clean data. If not, we can export a markup layer pinpointing exactly where the remaining non-conforming objects are. So let's take a look at a quick before and after conformance check. Our kickbacks rerun is now at 100%. And if you remember from earlier, we had it at 99.98. So one of the things I do want to mention about these essential geometry checks is that they have been written generically. We didn't have to write multiple versions of this kickbacks rule just to run it on every single class in our dataset. Notice here how it checked 8,361 objects. It matches the exact number of the total objects that we read in. So let's talk timings for a second here. So it took a little over a minute to run through the entire data validation and auto cleanup workflow. The reason behind this performance is that One Integrate operates on a spatially optimized object-oriented disk cache. So what that means is every single feature that gets read into the cache is automatically indexed at the beginning. So it makes it easy for a rule to call on each feature even as they increase in complexity. Let's take a small step back here. So in the NextGen 911 scenario, how can we ensure that the submitted data is consistent with the NINA GIS data model? Well, as you might already figure it out, you can definitely configure a rule that would automatically map the schema, but another way is to have it set up in the data store. A data store is a term we refer to any external source of data. So within this data store, I can select what type of data I want to read in. On this list of data store types, we can see that OneIntegrate is in fact data agnostic. So it doesn't require you to have a spatial component to your data. This is how we're able to read in our CAD drawing file or drawing exchange file formats, our flat CSVs. We can even connect to a database sitting in an SDE, SQL Server, Oracle, Postgres, and so on and so forth. Our developers continue to expand supported data format, with the newest addition here being Google BigQuery. Once we upload our data, we can verify how we want to map its schema. This is where we can rename how each class is loaded, as well as their associated attribution tables. This schema mapping step ensures compatibility with the rules that we write, allowing them to be reusable. So we can actually use our data store as a context to our rule writing. And this allows us to write our rules to match exactly which classes are being brought in. So from here, I can pick and choose which class I want to write a rule against. It also gives me access to the entire attribute table. Being that these rules are based off of a uniform set of standards, we don't necessarily need to have everyone in the organization writing rules. You wouldn't want to have too many cooks in the kitchen. So this is where our One Data Gateway solution comes in handy. One Data Gateway is a self-service web portal that's built on top of OneIntegrate's rules engine. So what that means is it does have the same functionalities to perform data validation, data integration, and enhancement. So let's say that I am a contractor for a number of LA County's jurisdictions, and I've been given access to submit data to the county on their behalf. So after signing in to my data gateway, I can see which workflows LA County has assigned for me to run my data against. So let's go ahead and make a submission on behalf of the city of Palmdale. I am simply clicking and dragging a zipped up Esri file geodatabase in here and hit continue to give it a second and try to map the submitted schema versus the expected schema in the rules. So it looks like our data has been mapped over successfully, but if it hadn't been, we can certainly review that. So we're seeing the same schema mapping flexibility as what we saw earlier, and we can define how our classes and their attributes are loaded in. And then once we're satisfied, we can save that, go ahead and kick off this session. So this is the exact session that we just ran using OneIntegrate, and it is still actually OneIntegrate's rules engine that's running under the hood here, just that it was wired up to One Data Gateway to give us, as data submitters, an opportunity to see where our data stands in terms of the quality standard that LA County wants us to meet. So this is very similar to how the state of Maryland is trying to roll out One Data Gateway to assist their counties. And again, it's getting their data 911 ready. So currently the state of Maryland, they host the NINA rules on their server using OneIntegrate, and they ask their counties to submit their addressing data to them. These counties simply upload the data and run it through the rules. If there are any kind of issues in the data, they can download a markup layer identifying where those issues are so that they can actually address them. Once they've cleaned their data, they can also upload it again. If the quality of that data is at 100% conformance to the NINA rules, the session in Data Gateway can even be set up to deliver that data to the state. So effectively what's happening here is we're automating the data supply chain. Let's take a look at our results here. So we submitted our data, ran them through the exact same rules that we just saw earlier, seeing the same non-conformance rates, and we can export the results here as an extra step. Other resources that we have here upon finishing a submission is we can once again download a copy of the input data that we submitted. We can download a copy of the output or the clean data with the markups, but we also have this PDF report in here that's been auto-generated. This contains the entire session run of what we just finished. And this is nice to keep, especially if your organization asks for metrics to be recorded for each and every time you submit your data. There are additional resources here to help keep track of data submissions as well, which we call our dashboard. So right here we're seeing metrics on the top violated rules on the data that I just submitted, how many submissions I make per day, and the trend of conformance over time each time I do make a data submission. Another way to implement data updates is by running a change detection process where you're essentially comparing two vintages of the same data. In the case of Collin County, Texas, every time they received updates from their local jurisdictions, they would pastry cut and replace the entire road network using their county boundaries and their city boundaries. So what this process entailed was manually stitching the data back up along the edges. So as you can imagine though, that they were spending a lot of time updating data this way. And because they were cutting and pasting, they would also lose the metadata and the history as the process continues. Blowing data away and replacing it entirely does seem like an overkill solution, especially since for the most part, you wouldn't really be expecting such dramatic changes in road networks that rapidly. So they asked us to help them come up with a more efficient solution, which would be to deploy a change detection process instead. One integrator allows you to load multiple data sources in the same session, so we can pull in the source data and the submitted data together, and then run them against the same set of business rules to help determine how the two layers interact. Do the geometry stay the same? Are there differences in bearing? Do they have the same address information? So on and so forth. From there, we can have rules that generate proposals on features where we do have and see those changes. In the same workflow, we can export those proposals out for manual review, or simply go ahead and apply those changes automatically. This sounds familiar because, as Brian highlighted earlier, this is basically the same process that Census has implemented for the Tiger data versus partner data road integration. Speaking of integration, One Integrate offers more than just GIS to GIS data processing because, again, the rules engine is data agnostic. So not only can you read in multiple data sources in the same session, but also multiple data stores in different data formats. And one of the data issues that Cuyahoga County out of Ohio wanted to address was between these two departments that were maintaining different information for the same data type. So in this case, we were looking at the tax parcel information from a computer-assisted mass appraisal or a CAMA system and parcel boundary shapefiles that were maintained by their GIS department. By running these two datasets against the same set of business rules for parcel data, we're able to determine records with conflicting information and facilitate automated integration between the two sources. So more importantly, we're able to identify records that are missing between the two. In the UK, we ran a very similar exercise with Northumbrian Water and United Utilities. They found out that there were hundreds of water clients that they were not billing. Another use case that Brian mentioned was our work with Google, so this would be the last one I'd like to highlight. This is in the asset management arena. Traditionally, facility data is created using CAD software, and they are managed through database systems like Archibus. Also, they are managed by asset management systems like IBM's Tririga and Maximo. So we can take advantage of One Integrate's capacity to coordinate a standard set of business rules that we want our facility data to follow. One Integrate can transform GIS data from CAD. We can extract floor areas, floor lines, and points as feature layers and cross-check that with other facility information being maintained by an asset management system. We then synchronize our CAD-derived GIS and the asset management system being utilized by a facility manager. So for example, in the rule logic that you're seeing on this slide, we can validate that a room object in the asset management database has the correct square footage based on the actual calculated area of the room's GIS geometry. So through One Integrate and One Data Gateway, we've submitted data to test some validation rules against them, and we were able to receive instant feedback results. We've also seen how these can help ensure that submitted data doesn't pollute your master data by only delivering your data if it meets the business rules that you have in place. We've also seen how these can roll out updates to enhance your data and keep it current and synchronized. So all of these steps promote data interoperability, which is really the core of having effective data quality management processes. We want it to be an ongoing process of collaborative data sharing. As you're thinking about these capabilities and how much your organization can benefit from a process similar to these use cases, I'd like to acknowledge how challenging it could really be to decide, where in your current workflow new data quality tools like these might be most painlessly introduced. But I do want to say that we are always excited to try to come up with new solutions for our data quality tools to work with your current spatial data infrastructures.
Melissa, I, and the entire One Spatial team want to thank you for your participation in today's presentation and your overall support for Virtual UGIC 2020. Please reach out to us directly if you have any questions or would like to schedule a call to discuss some of the items we covered in a bit more detail. We look forward to working with you. One Spatial, ensuring the compliance of your data for use across your enterprise.